Hello, and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. Your host is Tobias Macy, and today I'm interviewing Manos Koukoumidis about Oumi, an all-in-one production-ready open platform to build, evaluate, and deploy AI models. So, Manos, can you start by introducing yourself?
Yeah, thank you very much, Tobias, for having me here today. I'm Manos Koukoumidis. I'm the CEO of Oumi. Until about 9 months ago, I was at Google Cloud. We're supporting all the natural language AI services. Also, had bootstrapped the efforts for Palm. That was the model, as we called it before Gemini. Led all the whole V team until we went to general availability in May of 23 before it was rebranded as Gemini and moved as an effort to DeepMind. And yeah, before that, spent some time at a startup at Meta working on conversational AI. Microsoft, where I was building something like ChatGPT in 2016. All these things now that we say, embedding-based retrieval and RAG, we were doing them back then. The only difference is that we're using a little bit older technologies, LSTMs for generation. There were no transformers at the time. And yeah, before that, I was doing a PhD on on-device AI.
And do you remember how you first got started working in the ML and AI space and why you've decided to stick with it?
Yeah, that's a great question. So I started actually my PhD research on what was called Internet of Things, distributed sensor networks, and things like that. But right when I was starting was when the first iPhone was coming out. And I go back to my advisor saying, you know what, one day everybody's going to have one device like this. It was way before iPhone became so popular. And all these devices, they had all these sensors and all these ways to collect data. I was like, you know what, you need to be able to do something with all this data. And that's how I got into machine learning. And then soon after I graduated and I went to Microsoft, then I just started working with NLP way before Google, Microsoft, and many others started announcing that we're an AI first company. I was already working on AI between PhD for 4 or 5 years and then already at Microsoft for another 3, 4. So I was already very deep into AI, and it was clear to me that's gonna be the way things go. There's all this data, you need to do something with it, and it was just fascinating or intoxicating to have such a powerful tool to do something with data.
You've mentioned a lot of your background and the fact that you're building Oumi. I'm wondering if you can just give a bit of an overview about what it is that you're building and why you decided to leave what you were doing at Google and start this new venture at this time.
Yeah. So Oumi is a platform and a community to advance frontier AI in the open. This is exactly the opposite of what I was doing before at Google. Even before ChatGPT started, like before I was announced, a couple months before that, I was starting the effort for what became Cloud Palm, and then again rebranded later as Gemini. And even within a couple months into developing and ChatGPT coming out, there was quite a few enterprises like, okay, I've tried ChatGPT from OpenAI. I'm happy to try Palm as well, but can I get the model myself so I can use it the way I want and change it the way I want? And we're like, no, sorry, it's a black box. You can call it through an API. So I started realizing back then, how limiting it is for many enterprises to expose this powerful technologies as a black box behind an API. But then what made an even bigger impact on me is that I started realizing that, I knew for many years that AI is going to be very powerful, but I started realizing that these foundation models are being used now and they're going to be used increasingly for almost anything. People use them for material science, climate science. People use pre-trained language or multimodal models to solve partial differential equations, and even healthcare, or even, everything, like again, including healthcare. And when you have something that is so foundational, it should be like a utility, right? Something that's going to be powering everything in science and industry. It's just a disservice to humanity to put in a black box just so that some companies can freely monetize and then impede the progress of science and all these other enterprises. And I was like, okay, philosophically, it's a bad thing. We should be a more accessible technology. But I was like, okay, this is philosophically the right thing to do. But what about practically? Would that ever be a reality? Because all these large companies brag about how many GPUs they have, and that's their moat, and it's very hard for anybody else other than them to do it. But then I started realizing that there was a lot of tailwinds. There's a lot of all the cloud providers, unless they are, as I say, unless they're one of the few aspiring AI oligarchs, those few companies that know who they are. Nobody else wants closed source AI. Everybody wants open source AI to succeed. All the other different cloud providers, they want there to be a competitive open source model so that they have something to serve on their clouds. All the accelerator providers, including NVIDIA, AMD, and others, they want there to be strong open source model so they can optimize also their hardware on them. Because otherwise, everybody's going to go use the closed source model on the specific accelerator by that closed source model provider that is optimized across software and hardware. So, and then even consumer companies, like Mark Zuckerberg said, it will be very problematic for us, even a company like Meta, if we have to go to one of these closed model providers to get access to the AI that we need. Very problematic. It's a key powerful technology. It's going to be used everything what we do. We need to have free access, unconstrained access to it. So when I realized all these tailwinds, like, okay, philosophically it's bad for humanity. There's all these tailwinds, all these big players in the ecosystem that want open source AI to succeed. And then on top of that, I started realizing that it's actually such a complex technology. It's not just about the GPUs. And arguably, if you have somebody like Meta or somebody, or one of these big companies putting in the GPUs to pre-train the model, then it's more about how many creative minds do you have that could spend time to improve those models, especially with post-training, on all these different capabilities across all these different modalities. And then it's more a matter of a community, about having many smart people that can iterate and improve these things in parallel, and less about having a huge cluster. So yeah, I started realizing that actually community would be a more powerful mode, a more powerful thing than having more access to GPUs within a single data center. And a combination of those, it's philosophically bad for humanity. Practically, it can happen. Actually, it's the most plausible scenario that the best AI could be developed in the open by a community with all on eyes on it to both advance faster and safer. I was like, this is just way too compelling. I should just go build it.
On that note of open versus closed in terms of models, there's been a lot of conversation around what that even means, where the initial batch of models that were available for people to download and run were termed open source. And then there was a lot of debate about what does that even mean for a model to be open source, because it's not just the code, the data is equally important, as well as the parameters that go into training and tuning, etc. And in terms of models that can be truly termed open source, there have been a handful. The most notable one that I'm familiar with is the Olmo and Olmo 2 models from the Allen Institute for AI. And I'm curious what your thinking is, particularly in the context of what you're building at Oumi, what it really means for a model to be open and open source, and what you're focused on enabling along that spectrum, and any lessons that you've learned from some of those precursors, such as Olmo and I think the Nemo model, the embedding model as well, at least.
Also, really, really great question. So starting from the definition, so we're on the same page. What do we mean by open source? In my mind, for something to qualify as open source, it means that somebody else could reproduce what you built and extend it and make it better. Which means, at least by the OSI definition, which is very comprehensive, that it should be open data, open code, open models, open weights. Because quite often, as you mentioned, most of the companies, they just release the weights, they just release the model, and they say this is open source. But this is not really open source, again, not by the OSI definition, which I think is very accurate, because to be something that translates well to AI, again, you need to have all these three ingredients so that you can reproduce that work. So I think this is the very bare minimum. And as you mentioned, AI too, with almost one of the very few organizations that hit all these 3 points. One other thing, though, that we have as a key goal is we say, okay, it needs to be open data, open code, and then what you develop the models, the way it should be open as well. But also should be open collaboration. And we mean kind of like two things when we talk about this. It means that, as I mentioned before, that it's not necessary for somebody to theoretically be able to reproduce the work and extend it. It needs to be easy and practical, and it needs to be inclusive. So what I mean by this is that there's quite a few open source solutions, open source, actually a handful, not quite a few, including AI2, but it's very important that any of these things are very easy for anybody else to reuse and experiment to continue advancing those technologies. If you don't make it easy and you say, okay, I release my code, my data, everything, and yeah, if you try hard, maybe you're going to be able to reproduce it as well. it still impedes greatly the community to make progress. So that's one key element, making it easy, starting from there. You know what? It should be very easy for somebody to go and reproduce and then extend what I built. And the other aspect is that because actually it's such a complex technology, and actually our aspiration is to do, and we're already starting to do that, anything that it would take to help the community to collaborate and contribute. For example, this means encouraging and having efforts that encourage anybody in the community, not just a few selected contributors or partners that we have from a university or two, but anybody in the community say, you know what, you want to contribute? Here's all the different ways. And we're going to structure the efforts in a way so that depending on your background, you're more technical, less technical, you can still find ways to contribute. Because again, it's a technology that needs all hands on deck. It's extremely complex. And that's why I think many of the existing closed model providers, they are failing us. You know, some areas they're not, or many areas they're not as advanced or as safe as they should be. So that's what we aim to do. Again, the open data, open code, open models, but also open collaboration.
Collaboration is another interesting aspect in this ecosystem because it's not as straightforward as just opening a pull request on GitHub and offering a patch and waiting for it to get merged, because in order to collaborate on the model itself, you need to be able to, as you said, build it, test it, evaluate it, and it's a much more lengthy process to doing all of that versus just let me clone a repo, make a couple lines change and push it back up, where you can have that rapid cycle of iteration and adoption. And Hugging Face has been the focal point for a lot of the community building around the kind of open models, both in the era of generative AI and large language models that we're in, and multimodal models, but also even leading up to that. And I'm wondering how you think about that aspect of community building, collaboration, and the role of the community in terms of being able to actually iterate on those things, and any of the supporting infrastructure that's necessary to be able to facilitate that rapid adoption and collaboration and testing and evaluation.
Yeah. Very interesting question as well. So quite often when people talk about, and we talk about all this frontier AI and doing a collaborative open source way, indeed, models are a big part of this. But actually, I would argue it's about the overall ecosystem, because you can develop the models, but unless, again, you have all the other tools, better data pre-processing, you improve all the pre-training, especially the scalable distributed training algorithms. You have great implementations for different RL techniques, like the new GRPO that DeepSeek used. All of these things are actually just you could say pull request. Somebody can set the pull request and contribute. And having such a powerful ecosystem that helps the community to do this research end to end, and I can elaborate a little bit more on what I mean about this later. It's also as important as the actual model itself. Now, when you go to the model development, it's actually also something that, and this may be less intuitive to at least most people that I talk to, but it's also something that can be easily done across a big community. The good news is that quite often for many of these improvements, especially when you talk about post-training, which is massive opportunities, most of the latest improvements for the models have come from post-training improvements, is that somebody could test those ideas at reasonably small scales, like a 7, 8B model, which you don't need so many GPUs to do. And then, it may be up to a bigger organization like Meta, perhaps ourselves or some of our partners, to say, you know what, okay, we're going to take all these great recipes that the community tested at small, medium scale across all these different capabilities, across all these different aspects, and then combine them together to put them and train a bigger model, just because, perhaps some university didn't have enough resources. So anyway, so the meta point is that the improvements don't need to be done directly to the frontier models. They can be done at small to medium scales, which are very accessible to the community. And those improvements can be, if not, let's say, deeper architecture improvements, even just data improvements. This can go a long way. Or algorithm improvements, like, hey, do GRPO, and here's how I tested this. And now, go test it on many more, at a much bigger scale. So that's why there's so many such contributions that an open community can do, again, at a small scale. And then you can combine them to train a bigger model one day by some bigger organization. And the things that you need is, again, to have an infrastructure that lets you go through all the different steps that you need, whether you are curating new data, synthesizing and curating new data, you're experimenting with some new training algorithms. So it's good if these are implemented and readily available to you, also reasonably well optimized, so you're not wasting your limited, perhaps, GPU cycles. And then even things like, okay, you tested, you build what you want to do, and you want to evaluate it to make sure it improved on a certain capability you're working on, but it didn't regress on everything else, because then it's not as meaningful. But even that currently, it takes a lot of effort. You have to integrate, I don't know against how many repositories so you can test foundation models comprehensively. And it shouldn't be like that, because all that it's impeding anybody in the community to make progress. And by the way, that's actually what we're doing with Oumi, to make all these steps across end to end easy, so that it's easy for anybody in the community to make these small contributions that, in a way that they add up, because they're all done in the same end to end platform. That all the contributions they did are fully recordable, and then easy for anybody else to go and combine them. So, you know what, I'm going to take that data, make sure that this guy created with that, and then combine them together.
So, digging into Oumi itself, as I was preparing for this interview, I saw a couple of references to the fact that you're aiming for it to become the Linux of the AI ecosystem, where it is the common substrate that becomes as natural as water to fish or air to people living on land. And Linux, even itself, never actually set out with that mission. It was just, hey, here's something, and then it just gained adoption because of the fact that it was accessible, people could use it. I'm wondering what you see as some of the challenges to building that type of momentum for Oumi, and some of the ways that you're thinking about greasing the skids to be able to actually start that snowball rolling and build up the momentum needed for it to become as much of a de facto standard as Linux has become.
As you mentioned, it's hard to plan and say, hey, we're going to be the Linux of AI. But that's indeed the aspiration. And more than, hey, we think that, we should be the Linux of AI. What I tell people is it's really important that somebody that has our strategy, let's say if we fail, I really hope that somebody else with our strategy succeed, because it's very important for humanity, every single enterprise, sciences, humanity, for something like that to exist. And usually when I use the term also Linux is for people to relate to something they understand, that, the same way that Unix had come out, everybody said, this is the best technology developed by, I think, the best engineers in Bell Labs, I think it was, until Linux came out. So, it was not actually as good at the beginning, but because it was flexible, open source, people say, I can take this, customize to my needs, and it's going to be actually as good, if not better, than the black box, because I can change that. And then I have all the benefits of open source. Again, I can have full control of my own destiny. It's actually lower cost. So, and that's what we want to suggest to people, that, you can use the Unix because now you think it's easy. But if there's a Linux that is almost as good, and actually I would argue better, and you have all the benefits of open source, would you not want that? And the way to success, because you said you can't say, hey, this is the Linux and the whole community just flocks, it just doesn't work that way, is to make sure that what you build, the way, again, when Linux first came out, that it provides value to solo researchers or solo organizations to use it. And again, like Unix, say, this is a more flexible alternative. It's as good, even if it's a little bit less, let's say less good, at least because you can customize, you have all the control, you have all these benefits. You can make it at the end to become a better tool for you than the black box. And then more and more organizations use it. Again, the same thing happened with Linux, to the point that the community slowly builds up. Just also at the same time, as I mentioned before, we're very intentional that while we want this to be a powerful tool that makes sense for solo researchers or for solo organizations, that we have all these efforts that encourage participation, that make it easy for people to contribute and others to build on the work of each other. Because these things may not be intuitive. If you don't design for them, they don't happen by themselves. And yeah, hopefully that's the hope, and we have seen very good traction so far, that more and more people find it useful, and they all help make it better for the benefit of all of us.
In the AI ecosystem as well, for a long time there has been a large number of tools available that you can pick and choose and cobble together, even more so in the Gen AI ecosystem, where there seems to be a new tool every day, especially with the fact that so many of those tools can be generated by AI. And there have also been some efforts at managing that end-to-end flow of user experience. I'm thinking in particular in terms of Metaflow and ML flow, for being able to manage that bridging from local development through testing and evaluation and experimentation to infrastructure and deployment. And I'm curious how you have approached the work that you're doing in Oumi to address that end-to-end need, and figuring out what are the shortcomings in the existing solutions that need to be addressed as you build out this platform.
So quite often people ask me about this also, in relation also to other frameworks like Hugging Face, how, what is exactly the things that you're trying to do different? What's the problem you're trying to solve. And partially also the motivation for how we and why we started this work, besides all the reasons I mentioned earlier, were discussions with two academics from CMU that then became over a dozen, actually 2 dozen of academics. And they were all telling me the same thing, that yeah, there's tools like Hugging Face. Yeah, you can also talk about high-level orchestration tools like Airflow, and things like that. But for my students to be able to do this research on foundation models, it's way harder than it was 2 years ago. For one, none of my students has done multi-node distributed training, meaning to scale a bigger model. And it's not that we have a couple dozen GPUs. We don't have too many. But we could do it. It's just from the framework perspective, from the software perspective, it's just too much friction for them to figure out how to do all these things. And then I mentioned even just evaluation right now. You can say, yeah, I support evaluation, but all the different benchmarks that are out there, you have to integrate with 10 different repositories or many more to be able to access all of them and use them and evaluate what you are doing. So, and that's what we set out to do, that we said, okay, we're not going to reinvent the wheel where we don't have to. It just doesn't make sense. But we're going to make sure that there's an end-to-end, fully flexible open source platform that provides all the tools that somebody typically needs, all the way from data that is standardized. Because yeah, you could say data sets are on Hugging Face, which is great. Actually, we really love Hugging Face as well. But quite often they come in many different formats. So you know what? The ones that matter, we're going to standardize them to the same format. At least we have converters to put them to the same format. So if you want to use them for your research, you don't have to, every person out there, they don't have to reinvent the same converters. And then you can easily consume them. And then for different training libraries, whether you're using TRL from Hugging Face or a custom training loop we created that is more easily extensible, or let's say Tortune or any of them, you can still try all of them within the same unified API. You don't have to figure out how you can integrate with each one of them every single time. Again, all the different post-training techniques, again, readily available. Evaluations, again, you can have all evaluations without figuring out how you can integrate with all these different libraries. Actually, to give you an idea, Tobias, we even go a step further that says, hey, you even want to evaluate closed models like Gemini, Anthropic? Yeah, you can do that as well. You can just define one you want to evaluate once. Just put your API key from OpenAI or Gemini. You can even evaluate those as well. So anyway, that was the idea, that that there was way too many friction points that should not exist. And there was a huge opportunity to make it easier for the community to do this type of research. And at the same time, because you have something that works end-to-end, you don't have to integrate with 10 different repositories. The key thing is that it also facilitates a lot to have contributions that are fully recordable and reproducible. Because what was happening before, and what we're hearing from many PhD students, is that also in academia, because they would struggle with the same, is that for some research that they saw and they want to reuse, the authors used this repository, then some ad hoc hacky script to integrate with something else and do the next step with something else. But there's nowhere the whole process recorded, let alone in a way that's more standardized and easier for everybody else to reuse. So that's kind of like a little bit of the high level goal. And we had people that said, oh, there's all these tools for example, distributed training. I haven't managed to make it work for a year. So okay, try this. It shouldn't be any harder. And you can run it on your cluster, just change your deployment. You can also put GCP, AWS, Azure, whatever together, Lambda, wherever you get your compute. And as we tell people, it shouldn't be any harder than this. So that's been the goal.
In your work of building that end-to-end experience, managing that flow, the experimentation tracking, contribution tracking, how did you approach the design and architecture and component selection to make sure that you are building it in a way that is sustainable and maintainable, as well as adaptable as those components either cease to be maintained or get replaced by newer and better, et cetera?
Yeah. Really good questions. Right now, as it stands, we're an organization of 11 people. Because of the constraints, but also at the same time, because it's I would say the right thing to do, we said we're not going to reinvent things that we don't have to. If there's already established tools that work well, we're going to reuse them. We're going to try to fill in the gaps or grease things wherever there's friction points, standardize things wherever they have to be better standardized, like the data sets, for example. But we're going to build on the shoulders of giants. We're going to build on top of all the great things that already have happened in open source. To give you an idea, this is built based on PyTorch. For core capabilities like inference, we use the most common inference frameworks like HTLang or VLLM. For training, as I mentioned before, we use TRL for Hugging Face because it's very commonly used with our own custom training loop. Tortune is also now being integrated. For deployment, again, we use all the most common technologies like VMs with Kubernetes. We use a lot of SkyPilot wherever we can to deploy to different clusters. Wherever not, we use our own implementation. Yeah, Airflow for orchestration. We have even integrations with weights and biases, TensorBoard for observability. All the things that work well and people like. We say, we're not going to reinvent the wheel. But as I mentioned before, there's still a lot of gaps or friction points that had to be smoothened out. At the same time, though, there is some things I would argue that they're still missing in the ecosystem. For example, while there might be some solutions, there was no great solutions that help enterprises use these AI technologies reliably in production. I'm sure you've heard about things like hallucinations, safety guardrails. For example, there are some good solutions out there, but we think much more needs to be done to help organizations, because organizations are still struggling with these things. And they say, this is still the reason why we cannot trust these things to put them in production. So yeah, again, all in all, build on the shoulders of giants, do not reinvent the wheel. Unless we should only build something ourselves from scratch, unless there's a very good reason to. Yeah, just put the focus on those specific things that, again, are missing right now. They're not very strong offerings.
As far as the adoption, both of Oumi, but also of building and maintaining your own models, a lot of the work that has been done till now by different teams is to take a model off the shelf, whether that's a Llama or Mistral or what have you, maybe do a little bit of fine tuning, but typically just build a RAG pipeline, maybe host it on something like Amazon Bedrock or Base 10, or just use one of the APIs and then build all the scaffolding around it. Whereas you're focused specifically on being able to enable the actual building and evolution of those foundation models. So we've already addressed the fact that there are challenges beyond just the code and access to data, because you have to have access to the necessary hardware to be able to train these models, because they're very compute intensive. You need to be able to have access to that underlying data, which there are corpuses available, but if you want it to be specific to your business, you need to have your own data to make it actually useful. And I'm wondering how you're seeing those barriers to adoption as far as hardware access, data access, and just the overall know-how to manage that impede the potential for adoption and building momentum in those organizations.
So arguably, many organizations right now may not have the know-how how they can best leverage these technologies, and I think that's why quite often they may just go use something like ChatGPT or the GPT-4o, any of the newer models. Just maybe change the prompt and play with it, because actually many of them realize, but perhaps I would argue the majority of them do not, that you can use an existing open model, and especially the moment you customize it with your own data on your own domain, you can get a way better quality than the model out of OpenAI, Anthropic, or Google as it comes out of the box. I had talked to many customers say, no, actually, you don't need to convince me. I've already tested myself, but I just struggle to experiment with open models because each one behaves differently. And now there's a new model that came out of, for example, from Quen, and I want to move from Phi to Quen, and it's so hard. And that's why we help them with this. But there's some other ones actually, as you said, that they just don't realize also about the potential and what they could achieve. And they are also daunted by the friction. Because again, what we hear from many of them is that it's too daunting to figure out what works in open source, how they should best combine all these different components to get their job done. And again, that's also one of the things we seek to make very easy. And as you said, we may not have a RAG and such compound systems right now built, but we have a growing set of, I think, over 200 recipes that says, if you want to train this specific model, let's say any Llama, Quen, DeepSeek, whatever that is, or Phi, of this specific size, here's a recipe, a configuration that says exactly what the best parameters and how you should go about training this. Even if you don't know what you're doing, you have no ML background, if you could just put your data on the same format, which any application developer should be able to do, and you just do Oumi train with the same configuration file, you should be able to get very good results. I would argue, perhaps 95% of what an expert would get, hopefully, if they play a lot and they tune all the parameters themselves. And very likely way better than, again, the black box that is not customized to your domain and task. So that was our goal, to make it very easy, because again, it shouldn't be hard even for those people to get to a good enough or much better solution than the black boxes. But then the more experienced you are, and as different organizations build up more and more technical expertise, then they can turn the big knobs, the small knobs, or even go to the source codes and adapt it. Okay, that being said, you also mentioned about data. Besides just saying, okay, put your data in the right format and train, we're also building utilities to help them synthesize and curate better data, to the point that, actually, right now, you may need to know a little bit what you're doing, but if you have a set of prompts, you can synthesize responses for even the biggest models. You don't have to worry about how do you do inference with these very large models, even curate and clean up your data using LLM judges and other automatic approaches, which actually arguably doesn't take a lot of expertise. But there's more and more things that we're doing to make it easy, because our principle is it should be as easy as the black boxes for those who don't have the expertise. And as they gain more expertise, then they can go deeper and deeper and deeper and squeeze out more and more quality. Because I think that's also the winning recipe for an organization. I tell to kind of people I talk to that if you consider yourself an AI first company, don't stay in the shallow waters of just playing with a prompt, because your competitor may not do that. And then you're going to end up on the wrong side of history. Start flexing your AI muscles. You could start for something like this. It's easy, and then go deeper as you learn and learn more.
And on that data portion as well, it's also difficult to know, unless you have already built up that expertise, how much data you need, what data you need to be able to actually build something that's worthwhile. And so I'm wondering what you generally use as a heuristic when you're talking to people of you need either X gigabytes or this many samples or this format of data to be able to either build your own foundation model or take an existing foundation model and fine tuning or et cetera, and just some of the ways that you think about those different gradations of capability.
Yeah, glad you asked. So this is arguably something where we need to do better right now, or at least we should have some guide or something that makes it easy for people, because there might be something out there, but I think there's a lot of value. Tell somebody, you know what, go to this one place. You're going to get some high-level guidance about what you need to do, and then even the commands, anything you need to do to get going, because that's where people struggle. So, I don't know where to start. It's just chaotic out there to figure out what is the right guidelines with which tool exactly to get my goal done. But overall, if I were to tell somebody in short what the guidance would be is, typically the idea is that the bigger the foundation model, the less data it needs to be aligned or to learn how to do a new task. But now you may ask how many. It could be as little as 100, a couple hundred. Yeah, maybe we go to thousands, maybe even better quality. But the best way is to do a learning curve and say, you know what, I'm going to start with 100 examples and see let's even start with 10. What is the quality I get with out of the box with 0? What is the quality I get with 10 samples? What is the quality I get with 100? And then go to 500, 1,000. And then you can see how the quality improves or how it starts to plateau and say, okay, I'm not getting more benefits. I should stop here. So yeah, the best ways to do it incrementally.
So for somebody who wants to start experimenting with Oumi, incorporate that into their development workflow, maybe even their inference and serving use case, what's the process for getting started? What are the hardware capabilities that they need? Where do they look to for data sources to start that experimentation and playing around if they don't already have their own data sets that they want to build from?
Yeah. So currently, Oumi is an open source library on GitHub, which means anybody can take it, download it, even on their local MacBook. You can, if you don't want to git clone the code, you can just install the library. And you could even train a tiny model on a CPU. Actually, we have some recipes because, maybe somebody wants to learn how they can go through all this process, but they don't have access right now to some of the bigger GPUs. So even on CPUs, you can train a tiny model if you want to. If you have an actual GPU, even better. And the good thing is that you can define, for example, the training recipe, what you want to train or what you want to evaluate once. And then all it takes is to change the deployment config. Again, not code, just a configuration. Where you say, for example, here's my GCP credentials and go deploy to 10 VMs, 10 GPUs there. And that's all that it takes, at least for all the major clouds. And we support, again, AWS, GCP, Azure, Together, Lambda, Rampod, and a few more perhaps I'm forgetting. Or you can put on your HPC. We have tested this to over 1,000 GPUs. And again, all it takes is just change the command. You don't need to, or the configuration. You don't need to write any code. And the idea was that assuming that you have the GPUs, the recipe have to be recorded once. And then again, the more GPUs you have, the more you can change the deployment to scale and do more and more. And also in terms of data sets and all these things, somebody gave us actually two different academics, a postdoc and another professor gave us the feedback that, you know what, actually this seems to be the best way to learn how to experiment with foundation models because it's very easy to use. And I think actually it is easy. That was the goal, the design goal from the beginning, that it should be easy, but still extensible, right? Should not inhibit anyone from going beyond what's over there right now. And yeah, there's already existing data sets that are integrated. You can just say, I want to use that alpaca data set or this other data set. You just specify with a name and then just automatically download from Hugging Face and you can start training. Or you can specify also your own if you want to, if you have something in your local directory, for example.
And to that point of extensibility, evolvability, what are some of the places that you have added some of those escape hatches for, I need to go deeper, build my own custom capabilities, or add in some additional dependencies, or I'm already using something like a, lane graph, or maybe I'm building my own deep learning models and I want to use that as the evaluator, just some of the ways that you're thinking about the extensibility of the framework to allow for people to pull it in the directions that they want, and then also some of the ways that you're thinking about contribution back to Oumi from people who have done that extension and experimentation.
Yeah, that was a very important design goal, and also relates to the previous question you had asked about. Hey, components come in and they go. Maybe there's some new technology in the future, right? Or you should just said something that somebody else wants to contribute. That's why making sure that we have a very good design that is with well-defined components with good abstractions was very important, so that we can integrate again with all the different inference engines. This STLang or VLLM or any other one, so that we can have both TRL or any other training loops that we define. So if you go all across the stack step by step, from the data set definition and standardizing also that format so that anybody can introduce their own data sets with the same abstraction, to, again, only the steps, tokenization, the trainers, the evaluation, even that is well defined, how somebody can extend it and create their own evaluation library or their own benchmark or their own evaluator based on the specific metric they want to define. Yeah, even for high level tools like, hey, here's how you can define your LLM judge, so you can do your own auto evaluations or your own automatic data curation. All of this, if you look at I maybe have forgotten some, but if you look at every step of the way, we say, this needs to be a very well abstracted components, so that it's like Lego blocks. People can easily swap them in, swap them out with their own implementation, and they don't feel that it's too hard to move away from the set of options that we defined. And that was again for many reasons, as you mentioned before, because technologies come in and go. Maybe there's a new one that we need to integrate ourselves in the future, or because the goal was to appeal not just to enterprise but also researchers, and we know they typically want to push the state of the art. They want to go beyond what's there.
So Oumi is very focused on building an open ecosystem to enable people to build open models, because the overall bend of the ecosystem in software and now in AI is that open yields better results and allows for more experimentation and innovation in the space. Also, Oumi itself is a business. You've taken some funding, so obviously that comes with some expectations. I'm wondering how you're thinking about the commercialization aspect and some of the ways that you're also making sure that the Oumi project and core capabilities are sustainable and are able to continue on in the event that the business behind it ultimately collapses or gets acquired or whatever the future might hold.
Yeah. So there was somebody else I was talking to recently from one of the national labs that was asking me exactly about this. And I mentioned that, it's an Apache 2 effort. Let's say something happens to Oumi, the effort can still continue in the open. But also going to a little bit to your earlier question, the goal was very intentional. We said, what type of organization should this be? And we said, the best way to have impact is if you're able to pull the right funds to make this succeed. And at the same time, you are an entity that doesn't just appeal to academic research, but also to enterprises. Because there's one thing I learned by leading enterprise AI service at Google Cloud for almost 4 years before this effort, was that enterprises, they will use an open source effort, an open source project, if that's the best alternative, but they strongly prefer to use open source offerings that are backed by some organization, let's say the Red Hat compared to the Linux, for example, because they know that if they get stuck, they're going to have support that's going to be there to help them, and there's going to be somebody that will likely maintain it. Because quite often there's so many other open source projects that are maybe started by different academic institutions. When the student graduates, the projects are mostly stopped. They lose the core people that were moving them forward. So anyway, that was the intention, to say, we need to be able to support both the academic community and enterprises. So that should be a sustainable company. But I think, these two, serving the open community, by the way, we're a PBC, a public benefit corporation, are not at odds. Our goal is to, by truly embracing open source, not just open weights, which is like a very, very pseudo open source approach, that we help promote open frontier AI in a way where our costs are not even a fraction, not even 1% of the cost of OpenAI and all these other organizations, which means also we don't have that pressure to monetize so aggressively out of these technologies. Actually, our key principle is that the core foundation and the general foundation models should be a utility. like electricity, like water. It should be something that is freely accessible to everyone. Everyone can contribute to make it better. The NVIDIAs, the Metas, all of these very already powerful entities. And then it's freely accessible to everybody else. And then if it's open like this and you don't claim it's your own IP and you are licensing it, you're trying to make money out of it, then it means that everybody can sign into the same, can contribute to the same goal. Whereas if you contrast it with OpenAI or Anthropic, they have to shoulder the full economic and human investment cost to advance the technology, which means then they have all the economic pressure to monetize and enough so they can be sustainable. So that's why it's a very different model. So, we want to promote this model where it's easier for everybody to chime into the same effort, and then we all shoulder the cost. We all put in the same human contributions, and then everybody benefits. And then for us, the things we plan to monetize is just the enterprise features that enterprises need. If it's something that the open community needs to promote this as a better technology for everyone, our thesis is that this should be unconstrained, no paywalls, nothing, and we help and support them. Because it helps us also have a better enterprise offering at the end of the day.
Absolutely. Another challenge in the overall space of building these models, evaluating them, is that there is a lot that we still don't know about them. Obviously, having an open ecosystem to have broader collaboration to bringing that forward and evolving the state of the art is useful to address some of those challenges. But for organizations who are contemplating building their own model, it also brings with it those risks of, well, what if the model says something that is embarrassing to my organization or gives completely wrong information or in some way harms my reputation or my business or my operations? And I'm curious how you are thinking about that aspect of model development, model evaluation in the context of what you're building at Oumi and the community elements of it as well.
Yeah, as you mentioned, Tobias, this is one of the arguably the biggest concern that we hear from enterprises about what's blocking them to using these Gen AI technologies in production. They say, we can't trust them. One, as you said, they may hallucinate or they may just say something offensive. They may go off the rails. They may just, maybe they just provide customer support, but they may suddenly start generating an objectionable poem. It has happened before. It was on the news. Or again, they may just say offensive things. Or maybe, again, we don't want them to start generating financial and medical advice. So there's all this, there's a sizable set of risks that come with foundation models because they're designed to be generic and powerful and generic, answer any question you throw at them. And that's why, that's why for actually you need to build these extra guardrails around them or inside them to make sure that they don't go off track. And also, you find a way to mitigate hallucinations because, again, their foundation models are always going to try to say something. And as I mentioned before, these are the main ways in which we are helping enterprise. So, what? We can help you build your model. If you have the expertise, you can use the open source platform yourself. That's great. If you need extra help, we can be there. We can help you. But at the same time, all these extra systems that you need to deploy this in production reliably to make sure they don't hallucinate or, again, they don't go off the rails. That's our things we can help. Actually, by the way, we haven't announced it yet, a hallucination detection solution that is by far the state of the art in the industry, also the most ergonomic one. Unsurprising has been resonating very well because it's a key challenge for enterprises.
As you have been building Oumi, onboarding people, building the community around it, what are some of the most interesting or innovative or unexpected ways that you've seen it applied?
I think it may be a little bit early to say because we only announced it a couple of weeks ago and there's so many people that are using it. And I would say we're just reaching out to say, okay, how exactly are you using it? How exactly are you building with this? Because we know from the questions we get from them that they must be getting already very deep into using it. But yeah, I was going to say, there's already a lot of impressive things that are being developed. There are some students that said, I want to use it to build upon it better partial differential equation solvers, as I was mentioning. There was actually an effort together that was led by researchers at UIUC. We also helped them a little bit to train models to develop a better agentic model that actually was beating GP4O in the leaderboards. Even actually was beating GP4O in several benchmarks, and it was beating Mistral Large, Gemini, Claude, across the whole leaderboard of tool use. That was the Berkeley function calling, I think it's called function calling tool use leaderboard. And anyway, there was like some very impressive results that they got. There's also other enterprises we have talked to, and they say, as I mentioned before, that we were able to use an existing open model like 5 from Microsoft and develop a better custom model than GPT-4o. But we now want to test Quen, or we want to test all these other new models, and it's too hard for us. And it's like, okay, great. Actually, Oumi does exactly what we need, because now we can go experiment and play with all these other models. And actually, that's another company that we're working with right now. Yeah, I think, and actually, that's actually what makes me very excited, that we're going to be, I think, soon surprised by what we see, what the community builds, because once you make it easy for somebody, it's just a matter of how far can they go with their own creativity. And actually, there's some more things that we plan to do very soon related to DeepSeek and capabilities that DeepSeek released to make it easy for other people to play around and do similar things. So anyway, yeah, I'm very excited to see what people do with it.
And one other potential downside of opening up the floodgates, as it were, for more people to be able to contribute to build more models and do more experimentation and testing, is that you then expand the paradox of choice, where right now there's already a plethora of models to choose from. And if you have a given task, or if you're just trying to say, I want something general purpose, there's a lot of question about, okay, well, which model do I use? And we have leaderboards for different use cases, but benchmarks are perennially hard to actually get any real insight from. Obviously, I can play with the different models, but that takes time. And so I'm wondering how you're thinking about that aspect of it as well, of there are thousands and thousands more models that are available. They all do great for your one use case. How do I figure out which one to build or which one to start from when I want to build my own? And just some of that aspect of choice and understanding the differentiation between those models.
Yeah, as you said, there's definitely that paradox of choice where so many different options. They're like, okay, where do I start? I'm not sure. And that may even kind of make them unable to act and move forward, because, like, okay, where do I start? And they feel daunted by all the selection and the options. But besides the fact that there's a lot of options, I think the thing that makes it even more problematic, as I was mentioning earlier, is that it's even hard for them to assess all these different options. So if you know you have so many options, there's so many things you should be trying out, but it's too hard because all of them, they need a different way to integrate with them, then it becomes even a harder problem for somebody to solve. And that's why, our goal was to say that, yeah, there's many open models, but you don't have to do all this additional effort to test every single one of them. You can just say the names and you can test them. We have some more thoughts in the future, as you mentioned. If we know a little bit more about the scenario that somebody has, we could say, you know what, just don't try these 100 options, right? I mean, this is your latency or this is your cost quality trade-off. Just try one of these 5. And it's easy, right? You just specify the names of the models and you can test them. And as I mentioned, you can even test them against the closed ones. And then, yeah, hopefully that becomes a much clearer option. The other challenge, I think you already alluded to this, is the benchmarks. Is that because what I described assumes that you have the benchmark available and it's just a matter of testing things out. That's definitely a challenge. There's many academic benchmarks. They've been contaminated. Quite often models have trained in some fashion on these benchmarks. And actually, the other problem is that sometimes they don't also align very well with the enterprise use cases. That's why one of the efforts that we plan to have in the future is to help enterprises build their own benchmarks for specifically their own use case.
And in your own work of starting this venture, building the business and technology of Oumi, working on bootstrapping the community around it and engaging with some of the early users, what are some of the most interesting or unexpected or challenging lessons that you've learned personally?
Well, for one, I would say has been very exciting and rewarding, because even when I first reached out to the first academics, again, this is some of the most reputable people worldwide, and they were so encouraging. Like, you know what, this needs to exist, but it's too hard for us to build it. Please go build it, and we'll support you. I'll say I was hopeful that academia would be supportive, but I was still perhaps somewhat surprised by how kind of unanimously excited they were about this. There's only 1 or 2 academics out of the, I don't know, 20 or something that said, no, I don't want to contribute. And it was because they had already some other affiliation with an enterprise and that was blocking them. But there was even some that had this affiliation, said, you know what, I have this affiliation. I won't name the companies or the academics, but at the same time, I'm a professor, right? So during my time as a professor, I can still contribute. So I'm happy to do that because, it's part of my academic research. So anyway, yeah, I was very surprised to see how eager people were to embrace this. At the same time, I think as, let's see, more on the negative or the more constructive side of things is, yeah, I would say, yeah, just the value you provide needs to be clear to people. We had quite a few people say, oh, I'm using this other library, why should I use this? And in lack of a better argument, actually, it was an academic project called Llama Factory. I told the student, give it a try and you tell me. And then they came back saying, oh, yeah, I can see that it was easier to use. With this other one, I was never able to do multi-node distributed training. I just got to work right away. But yeah.
And for people who are interested in building with AI or building their own AIs, what are the cases where Oumi is the wrong choice?
It's hard to imagine. Well, there might be some very narrow use cases where you may say, what, actually, yeah, for that use case, maybe that specific closed model is the best one. For example, if you're doing coding copilots, I think the models from Anthropic may still have a little bit the lead there. I won't be confident for how long this is going to be sustained. But if you're like, okay, right now, what is the best coding model? I think likely it's going to be one of the Anthropic ones. And especially if you want something that is very generic. Though, if you start going and say, you know what, no, I have my own code base, I have my own ways of doing software development, and I want something that is more customized to my own way of doing things, I would say, yeah, most likely, or almost certainly, you can get an open model and make it become a lot better even than Anthropic that is generally trained to be a general coding copilot. But besides this very specific use, I would say, yeah, again, for most other ones, open models will be very competitive, and especially if you want to say, you know what, it's great, this black box. It's a good starting point for me to see that this as a technology makes sense for me. But now I really want to differentiate compared to my competitors. I really want to maximize the value I can get out of this technology. Then I would say it's extremely likely that you move to an open model and you can get better quality, lower latency, lower cost, more flexibility, better private security. You can deploy whatever you want. I think it's going to be very few reasons why somebody should not be using the Linux of AI and they should stick with the Unix. And increasingly going to be even less and less, if any.
And as you continue to build and iterate on and evolve Oumi, what are some of the things you have planned for the near to medium term, or particular projects or problem areas you're excited to dig into?
I would say that for one, the platform itself still needs, it can still become better through our own contributions and contributions by others already doing. So already people who contribute new data sets and all sorts of different things. So there's still a lot of things to do to make it a better platform for all of us. For example, having better RL capabilities with GRPO. We just completed the integration just a couple of days ago, but there's still more things that we need to do to make it better usable and more powerful RL platform for everybody else. And actually, that's something we're investing on very heavily. The reliability features like hallucinations, especially those actually work really well right now, but the rest of the guardrails, these are things that we still need to put more investment to help enterprises. Oh yeah, and the thing actually that makes me actually very excited is we just recently started research efforts. When we launched, we had over 100 people that volunteered and say, hey, I want to help as a research collaborator, besides all these academics and students we're already working with. And we're starting now projects one after another so they can help collaborate and advance the platform. So it's actually something I'm very excited. We're just starting this right now. And day by the day, we're going to be starting more and more projects. And yeah, I'm very excited about all the things that they're going to be doing.
Are there any other aspects of the work that you're doing at Oumi, the overall space of open models and open source collaboration around these foundation models and model training, model serving that we didn't discuss yet that you would like to cover before we close out the show?
I think we covered a lot of ground. The only thing I would say, which may be, again, not as intuitive to many people, especially when they hear the Sam Altmans of the world saying, hey, we have that many GPUs, is that there's a lot that an open community can do, especially when you have already these massive pre-trained models that companies like Meta generously contribute to the open community. At the post-training especially stage, there's so many things that an open community can do, and they can and these contributions can be combined to develop jointly a better model and ecosystem, again, the platform, the whole ecosystem, that's going to be way better than OpenAI and all the other ones out there. So that's what I would say, a call to the community that, there's, you're not, powerless as perhaps, again, the Sam Altmans of the world may want to make you feel. We're only, powerless if we let ourselves believe that. And that comes from somebody who was leading the efforts inside of these large organizations. And I saw that it's more of a matter of how many intelligent people can you have that can contribute to such an effort, and less about, you don't need stockpiles of GPUs for you to be able to contribute. And I think this is good news for all of us, and it's good news for enterprises, the sciences, humanity, because it's critical that this succeeds.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gaps in the tooling, technology, or human training that's available for AI systems today.
Yeah, I think there's going to be, in terms of the technologies, there's a lot of powerful technologies, but the main problem, again, we're seeing is that it was very hard to make them more easily accessible, or especially in an end-to-end way. That, you know what, I can go there, datasets are standardized, I can, maybe for this use case, it's better to use this inference engine, for this one is better another one, or maybe I need to test both of them, because maybe for this specific model, this works better, for the other one, maybe something else works better. But putting all these things together so it's easy for somebody to experiment, so it doesn't become daunting and a huge lift for every single researcher or for every single enterprise, I would argue that was one of the main things that we're missing. The only very point solutions or very specific gaps were definitely the ones around reliability, as I mentioned before, for enterprise, where these areas where we're trying to help. But yeah, I would say this is the main thing. It was clear that the enterprises, community alike, they were missing a way to go through the whole workflow. Because when you build foundation models, when you do this research, it's not just training, it's not just data. You have to work through the whole workflow. And it's important you can navigate the whole workflow easily.
All right. Well, thank you very much for taking the time today to join me and share the work that you and your team are doing on Oumi. It's definitely a very interesting and exciting project. I'm very happy to see it out there in the open and in the ecosystem, and excited to see where it takes all of us. I appreciate the time and energy that you're all putting into that, and I hope you enjoy the rest of your day.
The pleasure was all mine. Thank you very much, Tobias.
Thank you for listening, and don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest in modern data management, and Podcast.init, which covers the Python language, its community, and the innovative ways it is being used. You can visit the site at themachinelearningpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at themachinelearningpodcast.com with your story. To help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.